Welcome to Brain Vision.
To solve this question, we have to calculate what is the magnitude of the acceleration, so then we can use Newton's second law to determine what is the magnitude of the resulting force. So how can we calculate the magnitude of the acceleration? Well, we have to make a vector addition. This vector plus this vector. What is the result? Well, let me do a drawing. We have one vector that points on the horizontal axis, and then we have another vector that points on the vertical axis. As a rule of adding vectors, we put the end of one vector on the beginning of the other vector. So we will put the end of this vector on the beginning of this one. The result is the following. Okay, now we have AY here and AX here. What is the resulting vector from this addition? It is this one. Okay, and this is the resulting acceleration. Note that this is a rectangle triangle. This is a 90-degree angle. Therefore, it is true by using the Pythagorean theorem that a squared is equals to ax squared plus ay squared, and therefore a is equals to the square root of ax squared plus ay squared. Then we can plug in the values that were given by the problem to calculate the magnitude of the resulting acceleration. It is the following. A is equals to the square root of 810 squared plus 1100 squared. And this gives us approximately 1366 meters per second squared. So this is the resulting acceleration. And it points in between the two accelerations. So it points in this direction, and the magnitude is approximately 1366 meters per second squared. Now, in order to calculate the magnitude of the force that is acting on the ball, we use Newton's second law. It says that the resulting force is equals to the mass times the acceleration of the ball. But this is the vector form of Newton's second law. As we are interested in the magnitudes, then we use the magnitude of the resulting force, which is not a vector, and the magnitude of the acceleration. The magnitudes are not vectors, they are numbers, so we can operate them as usual. So the magnitude of the resulting force is equal to the mass times the magnitude of the resulting acceleration. Then we have the following. The magnitude of the resulting force is equal to 0.43 times 1366. And this gives us a resulting force of approximately 587 newtons.